All right, example 7, graph y equals 1/2 sine of x minus 4 minus 2. So again, the book really likes to put these plus and minus numbers at the end. I don't. I prefer them at the front. I would want to factor things out. So for me personally, if I see that in my book, I'm going to copy it to my paper in the order I like it. So y equals the constant, it's plus 1/2 sine, and it's 1 times x minus 4. You don't have to put the 1 there, but I like to see A, B, C, and D staring me right in the face. It just makes me feel more comfortable about the whole problem. So I can see here that A is equal to -2, B is equal to 1/2. I can see C is equal to 1, and therefore D is going to be positive 4. I don't know why that's so long, but I'll run out of room here. All right. So again, A, B, and D are ready to go. They're going to help me do stuff, right? C is going to help me get the period. The period is going to equal 2 pi over 1. And the per dash is going to be pi over 2. Now, if the phase shift and the per dash don't agree with each other, they're not the same kind of number. This has a pi, that doesn't. You could go 4 plus pi over 2, 4 plus 5, 4 plus 3 pi over 2, 4 plus 2 pi. That's fine. For me personally, if they're not in agreement, I just go ahead and get a decimal approximation, and I'm sufficient with that. That's fine. So pi over 2 is about 1.57. We'll go with that. So just keep adding decimals. 4 plus 1.57 is 5.57 plus, and then 7.14 and so on. All right. And then notice we're starting at 4, which is kind of far away from 0. So here's a situation where I would probably put my y-axis way over here, all the way left. And that is so long for no reason. Shorter. Okay. I'm going to put a break on the x-axis. And this first dash is going to represent 4. And if I do that, I can go ahead and say per dash, I can go ahead and do this 1.57 here, or I can even do pi over 2 there. So it's not really that big a deal if I call it pi over 2 even. All right, but 4 and then dash 2, 3, 4, 5. So there's the beginning where we normally started at the origin, right? But now we're starting there. And I can see B is a positive 1/2, and it's sine, so it's going to start middle, top, middle, bottom, middle. If I put my dash here and my dash here, I could actually put all the dots in immediately if I wanted to. And this is going back to what I said on the last problem. If you wanted to put the dots in first before you put your numbers on the dashes, then you kind of get a feel for where the graph's going to be so you get things out of the way. So I can actually draw the picture right here without even having the numbers in yet. That's not very good though. Try again. Actually hit the dots. All right. Then, looking at the A and B values, that establishes the y-axis stuff. The center line is -2. We're going up 1/2 and down 1/2. So 1/2 bigger than -2 is -1.5. 1/2 less than -2 is -2.5. My y-axis. Just like that, I got the graph drawn. All right. Just to give you a visual representation of this compared to what we normally see. If I typed in just sine of x, all right, no weirdness to it, just sine of x. And then I type in -2 plus 1/2 sine of x minus 4. All right, and I'm going to set my window to go from, let's see, that'd be 2 pi, which is 6.2, about 10.28. All right, so I'm going to go from 0 to 10.28, and scale 1 is fine. And y min and max, I'm going to go -3 up to positive 1.5. That'll be a little bit below the bottom of this, a little bit above the top of sine of x. And that's fine. Doesn't matter what the scale is there. Hit graph. So here's my regular sine graph right there, that blue graph. That's the first period. That's the second period, and so on. Now there's my second graph. Okay. So 1, 2, 3, 4. This is where the graph starts. So let me actually drag this out so I can draw it. 1, 2, 3. This is our starting point here. And then all the way through one period, so there's the ending point, right? So this right here is what matches up to that over there. All right, and if we compare them side by side, let's see if I can do this. I just cut this here. See how gifted I am with this, or how non-gifted, one or the other. All right, and then I take that and I set an image transparency and go. Almost one full period. Missed by a smidge. There we go. Make it a little bigger. But if you just compare the size of them, that's twice as tall, right? Because that's half, right? And notice it got moved down because of that y equals thing, right? And it got moved to the right because of the minus the phase shift. So again, this right here matches up to the beginning of that. The phase shift pushed it. So again, if you imagine starting here, push it 4 spaces to the right, push it 2 down, and then the half makes it shrink. All right. So those are the influences those numbers have on where the graph is, what it looks like. And again, for the sake of what we're doing, they're all going to look pretty close to the same thing because we're, modifying some things so they all kind of look the same. But know that we're modifying things. So by saying, if this said 17 and this said negative 21, that'd be a really tall graph. But it's going to look like this because that's how we do it. Okay, I don't know where those dots came from, but they go away.